All right, everybody, we are here in our classroom about to do our Chapter 6 study guide together. All right, so let's go through this. Number 1, the average salary for the employee at Acme Corporation is $30,000 per year. This year, management awards the following bonus to every employee: $500 an incentive bonus equal to 10% of the employee's salary. What is the mean bonus received by the employees? All right, so let's write a linear function to describe my bonus. So we'll say B is bonus, and S is salary. And so my bonus is going to be $500 plus 10% of my salary. But we're here, not everybody, we're talking about averages. So we need to rewrite these using averages. So the mean bonus is 500 plus 10% of the mean salary. We know in this problem that the mean salary is $30,000. So I can plug that in. And I'm going to go through these pretty quick because I've already done my homework. So I'm just going to show you the setup. And a lot of these, I'm just going to assume that you can pause the video and put that in your calculator and get that the answer is 3,500. All right, so on average, I expect the bonus to be $3,500. All right, next question. Giannis Antetokounmpo, a basketball player for the Bucks, makes 52.4% of his attempted shots. What is the probability he will make 8 out of the 10 shots? All right, so since we have a fixed number of trials, I'm thinking that this problem is probably binomial. But let me check bins. It's binary because he made the shot or he didn't. His first shot we'll assume doesn't affect his second. The fixed number of trials is 10. And every time he plays, he's got that probability of making the shot. So therefore, I'm going to go with bins on this one. So we want to figure out what's the probability he makes 8 out of 10. So I'm going to do this the long way. Oh, first I have to define X, and that's make a shot. All right. And then we want to figure out what's the chance that he's going to make 8 of them. So that is 10 shots. He's going to make 8. The probability that he makes a shot is 0.524 to the 8th power, because that's the probability of success, and that's how many successes we want. Now we got to look at his failure rate. The opposite of 524, the complement of 524, is 476. If he made 8 of the shots, that means 2 he missed. Plug this into your calculator, or you can do binomial PDF. So if you want to use your calculator, you're going to do binomial PDF. N is 10, that's how many shots he took. The probability was 0.524, and K was 8. So either this or this, plug in your calculator, and you should get 0.58. All right? All right, what's the probability that the first shot he made was his 7th attempt? So this is assuming that he did not make the first 6 ones. So this one now is geometric. Because it's geometric, we need a new variable. We can no longer use the letter X because X is mixed to the shot. Now it's trials until shot made. So a totally different idea here. All right. So in this scenario, we've got a couple different options. I'm going to do this by hand. So we're saying that he's going to make his 7th shot. So he's got a 0.476 chance of not making it. That means he failed his first 6 and he made his last one. If you wanted to use the calculator, you could do geometric PDF. P is 0.524. Just starting to run out of room. And K is 7. All right. Okay, in question C, the probability it takes him at least 4. So numbers that are at least 4, all right? At least 4 means 4 or more. If I plan on using my calculator can only do less than or equal to problems. So I got to rewrite this as a less than or equal to problem. All right, so let's think about this. greater than or equal to 4? Well, that would be 4, 5, 6. The opposite would be, oh, I'm sorry. What's the probability it takes him at least 4 to make his first? So I'm sorry, it's still geometric. Sorry, this is why. I apologize. Okay, so 4, 5, 6, and so on is greater than or equal to 4. So this way would be 3 and below. So I'm going to put a 3 right here. Because it's an inequality, I'm not going to use PDF. I'm going to use CDF. And P is, again, 524, and K is 3. Plug that into your calculator, and you should get 1079. Now remember, as you do these, you should be pausing the videos, trying these and seeing, am I getting the same numbers? Because it's not going to help if you just sit there and just copy what I'm doing. You got to really figure out where are these located in the calculator and how do you do these problems on your own. All right, lastly, how many do you expect him in a sample of 20 to make, and how much can it vary by? So it sounds like we're going back to binomial. So the mean for binomial is n times p. So he's trying 20, his probability is 0.524, so that means he's going to make 10.48 shots. How much can it vary by? So that is the square root of n times p times 1 minus p. So that's the square root of 20 times 524 times 476. And that comes out to 2.23. If I had to write this in a sentence, I would say, on average, out of 20 trials, out of 20 attempts, I expect him to make 10.48 baskets, and it can vary by 2.23 baskets. All right, so you need to be able to write that in a sentence on the test. All right, let's look at the back side. On the back, a box contains, I don't know if you can see that. No, you can't. Okay, a box contains a $10 bill, 2 $5 bills, and 2 $1 bills. You get to play this game by reaching your hand in the box and removing a bill. What is the expected outcome of this game, and what can it vary by? All right, so I'm going to make a little table because there's a lot going on here. It's a little confusing. I'm going to let X equal my money. So this is how much money I'm going to make. So in this game, I can make $10, I can make $5, and I can make $1. There are, let's see, there's 1 $10 bill, 2 $5 bills, and 2 $1 bills. So it sounds like there's 5 bills total. So the $10 bill, there's a 1/5 chance of that happening, okay? Or 0.2. The $5 bill, there's 2 of those, so there's a 2/5 chance of that happening, or 0.4. And then this one is also 2/5, or 0.4. All right? Okay, so we want to find out what is expected. Expected means mean. So we want to figure out the expected mean. When you have a table, the formula for expected mean is the sum of every x value times its probability. So 10 times 0.2 plus 5 times 0.4 plus 1 times 0.4. All right, when I work that out, I get $4.40. So in the long run, I expect to make $4.40. I'm not always going to make $4.40. Sometimes I'm going to make more. Sometimes I'm going to make less. So we need to figure out the variance. All right. So you take the, that's the sum of every x value minus the mean squared times its probability. So the very first x value is 10 minus the mean we said was 440 squared times its corresponding probability. You're going to do that until you finish the entire table. You're gonna painstakingly and slowly do this in your calculator, and you're gonna get 1104. If you want the standard deviation, this is the variance. So you're gonna take the square root of 1104, and that comes out to 3.3. All right, that's how you find the mean and standard deviation of a table. All right, we've got some more word problems. Let's keep going. You have a 60% chance of winning a certain game at a carnival. What is the probability you will win the first time, but it'll be the 8th trial? All right, so you're not winning, you're losing a ton. All right, so here's our P. And so this sounds like it's geometric. So I'm gonna let X be winning. So the probability that I'll win on the 8th trial means I lost. That's me losing. If 60% of the time I win, 40% of the time I lose, I'm gonna lose 7 times, and I'm gonna win the 8th time. That comes out to 0.000983. All right, what's the probability you will win 4 times if you play 9 times? All right, now look at this. Now we've got a set number of trials. We are no longer playing until we win. So because we have a set number of trials, we know now it's binomial. We need a new letter. We'll call Y. Oh, I just realized I messed that up. It's not wins. It's trials until win. Trials until win. This one is wins. So in this problem, we were playing 9 times and we're trying to figure out what's the chance that I'll win on the 4th time. So 9 choose 4, 0.6 to the 4th, 0.4 to the 5th. All right, when you do the math, you can also do binomial PDF if you want. All right, what's the probability you'll win less than 10 if you, less than 6 if you play 10? Set number of trials, so it's binomial. So maybe you should write down before you start a problem whether you think it's binomial or whether you think it's geometric. So we said the problem's binomial, less than 6. Well, that's the same thing as less than or equal to 5. And the reason I want to write it down like that is that way I know to not put 6 in the calculator, I have to put 5 in the calculator because the calculator only does less than or equal to. So then I'm going to do binomial CDF, N is 10, P is 0.6, K is 5. When I work that out, I get 0.367. All right, last one for this section. How many trials do you expect it to take to win on the first try, to win your first time? So it sounds like you're going to play and you're going to play and you're going to play until you finally win. That's going to be geometric. The formula for geometric mean is 1 over P. The probability of winning is 0.6, so I think it'll take me about 1.67 trials. Again, remember, you're pausing the video, you're trying these problems out, so don't just copy me because that's not going to help you. I really want you guys to be pausing and trying. All right, we're almost there. Excuse me. It takes a washing machine an average of 45 minutes to clean a load of laundry, and that's with a standard deviation of 2.3. The dryer takes 55 minutes with a standard deviation of 1.2. How long does it take me to do the laundry, and how much can it vary by? All right, let's define some variables. We've got the washing machine, we've got the dryer, and and then we've got the total time it's going to take to do the laundry. So the total time it's going to take me to do the laundry is however long it takes to wash plus how long it takes to dry. So in this scenario, we've got 45 plus 55. So it's going to take me 100 minutes to finish my laundry. It's not always going to take me 100 minutes. Maybe I'm using a different machine. I'm in the college dorm. There's a ton of machines in there, right? So I got to check the standard deviation, all right? So I'm going to square each standard deviation, where I'm going to find the variance of each. And so that would be 2.3 squared plus 1.2 squared, and that comes out to 6.73. The standard deviation is the square root of this, so that would be 2.59. So I expect on average my laundry to take 100 minutes, but it can vary by 2.59 minutes. All right, and last one. A standard popcorn bag takes an average of 4 minutes to pop with a standard deviation of 0.25. Suppose that it's a normal distribution. Oh, that's nice. We know how to do those. Those are z-scores. So because that's a z-score, I know that I just have to do my pretty notation. The mean is 4. The standard deviation is 0.25. And we're trying to solve less than 4.4. All right, well, that's the same as x minus mu over sigma. When I work that out, 4.4 minus 4 divided by 0.25, I get 1.6. I'm just going to write 2 decimal places because it's easier to look up in my booklet. So I'm going to look up positive 1.60, look it up. When I do that, I get 0.945. There's a 94% chance that the popcorn will take less than 4.4 minutes. All right, guys, I hope watching me do those problems helped. I think you're going to do great before the test, and wishing you all the luck. Talk to you soon.